basic topic for today is functions. So what are they? We'll start with that. A formal definition is that a function is a relation in which for every input there is a unique output. All right, so at the core of the definition is the word unique. It means every time you put one thing in, you have to always get the same thing out. So if you think of a function, it's kind of like a machine that does something. And in this machine, we're going to drop stuff in the top, and it's going to spit stuff out the bottom. So for something to actually be a function, if we take like the number 3, we drop it into the function, maybe it's going to multiply that number or double that number, and it would then spit out 6. Okay, if we put the number 4 into the function, it's going to spit out the number 8. The idea of what makes it a function is that every time you put 4 into the function, it's always going to spit out 8. Now, it could be numbers, but it could be anything else as well. So it could be like eye color. So let's say we put student A into the function, and the function tells us what eye color that student has. That student has blue eyes. We put person B into the function. That person has brown eyes. We put person C into the function. That person has blue eyes. So the function is telling us what eye color the person has. This would be a relation that we would call a function. Now, if we switch the order, and we put the color into the function, that's going to be a problem, because we put the color blue into this particular function, it's going to spit out person A, but if you put color blue in again, it may spit out person C, because remember that person A and person C both had blue eyes. So this would not be called a function. So it means every time you put something in, you always have to get the exact same thing out. So, for example, the stuff that you put in is called the domain. So let's put in numbers 3, 4, and 5. And the stuff you get out is called the range. Now, the domain are like your x values, and the range are your y values. So let's say, like in our doubling function, we had 6, 8, and 10. So this relation right here would be considered a function, because every time you put 5 into there, you're going to get 10 out. Okay, it's always tagged to that 10, as opposed to something like this. If we had 3, 4, 5, something like this, where we put 3 into the function, and it gave us a 7. We put 4 into the function, it gave us an 8. We put 5 into the function, it gives us an 8. Now that's okay, because every time you put in 5, you're going to get an 8. Here would be the problem. If you put 3 in again, and it gives you something other than 7, that would mean that this is not a function. So the first one was a function, and the second one was not a function. And the reason the second one's not a function is because the 3 gave us 2 different outputs. Again, it has to be a unique output. You always have to get the same thing out from what you put in. So here's 4 examples. We want to try and determine whether or not these things are functions. The top row for each one, those are the domain, meaning our input values. And the bottom row is the range, meaning our output values. So typically for functions that we deal with, the input is the x and the output is the y. So for example, in this particular relation, you put input 4, it spits out a 2. You input an 8, it spits out a 4. You input a 6, it spits out a 7. In this particular case, this is a function, because for every input, you get a unique output. In this case, you input 3, get out 8, input 6, get out 9, and so on. Again, this particular case, this is a function. Now, a couple of things to make sure that you notice is notice that you can get the same output. Like here we input 8, got out 4. Here we input 0, got out 4. That's okay. But this particular one, this is not a function. And the reason it's not a function is because of this and this right here. If you input 3 and get out 6 the first time, then you input 3 and get out 2, that means it is not a function because the output is not unique for that input. Okay, again, remember if you input the number, you have to get the same number out each time. Whereas in this one is a function because every time you put in a 4, you get out an 8. So this is a function. Now, if I were to add one term in here, and let's say we input a 4 again and I got out a 6, that would mean it's not a function anymore. So this relation is a function. It doesn't necessarily, you can repeat your outputs. You simply cannot repeat your input. We're used to dealing with equations. Equations like y equals 2x plus 4 would be a pretty standard equation. This relation is a function. If we want to use correct function notation, it's written this way. And it said f of x is equal to 2x plus 4. This is our input, and then we take our input, multiply it by 2, and add 4 to get our output. So, for example, f is the name of the function. Every function has a different name. Some are called f, some are called g, some are called h. So I'll change that letter in front, and that simply is the name of it. If we wanted to find f of 1, that means we're going to take this and replace it with 1. So to find f of 1, we would do 2 times 1 plus 4. And so 2 times 1 is 2 plus 4 is 6. And so we would say that f of 1 is equal to 6. And instead of just writing 6 as your answer, I want to write the notation f of 1 is equal to 6. So I know for an input of 1, we get an output of 6, which in our old language would just be the coordinate 1 comma 6. This is simply a different way of showing that notation. So let's say we had a different function. Let's say that h of x was equal to x squared minus 2. If we wanted to find h of 3, we're going to plug 3 in here. That's going to be 3 squared minus 2. So it's going to be 9 minus 2, which is 7. So we say that h of 3 is equal to 7. Whatever we change this x to, we change this x to. So if we wanted to find h of a, that would be a squared minus 2. If we wanted to find h of q, that's going to be q squared minus 2. If we wanted to find h of x plus 1, that's going to be the quantity x plus 1 squared minus 2, which we would then want to simplify. This is going to FOIL into x plus 1 times x plus 1. So we get x squared plus x plus 1, and we have our minus 2 on the end. So when we add all our stuff together, we get x squared plus 2x minus 1. Again, that's h of x plus 1. So this would be our final answer. So let's look at this top example here. If we're given the function h of t is equal to t squared minus 2t, and we want to find h of 4, and that means we're going to change whatever we change t to here, we have to change these t to, so that's going to be 4 squared minus 2 times 4, so we get 16 minus 8, and so our final answer, we would say that h of 4 is equal to 8. In our next example, to find h of x, whatever we change t to, we make it an x. That's just going to be x squared minus 2x. To find h of x minus 3, that's going to be x minus 3 squared minus 2 times x minus 3. So we have to FOIL that x minus 3 squared out. It's going to be x minus 3 times x minus 3. We have to distribute the negative 2, so it's going to be minus 2x plus 6 on the end. So we have x squared minus 3x plus 9, and then the minus 2x plus 6. So we would say that h of x minus 3 is equal to x squared. We have minus 3x minus 2x is minus 8x, and 9 plus 6 is 15. In our last example, we're given the function g of x is equal to the square root of x plus 6 plus 4. So to find g of 3, we do the square root of 3 plus 6, which is 9, plus 4. Square root of 9 is 3. 3 plus 4 is 7. So we would say that g of 3 is equal to 7. To find g of 0, we plug in 0 for x. So we get the square root of 6 plus 4. Square root of 6 can't be simplified. It's irrational. So we can't add it to the 4 nicely. So we're just going to leave our answer looking like that. G of 0 is equal to root 6 plus 4. Now when we try and do g of negative 10, we get the square root of negative 10 plus 6, so that's the square root of negative 4 plus 4. This is an imaginary number. So when we're talking about functions, we're not going to deal with imaginary numbers. We are simply going to say that negative 10 can't go into that, so we would say there is no real solution. And the reason, again, there's no real solution is because if we plug negative 10 in here, we get a negative number, which means it's not in the domain of the function. And we'll talk about that later. The domain are numbers that we are allowed to plug in, and the range are the numbers that we're going to get out. And that's for the lesson to come.